In this video, we're going to do a quick analysis of the greedy coloring algorithm. We're going to look at, is it correct, which, kind of obviously is, but we'll also talk about, if it's correct, what does that actually tell us? And we're going to talk about how long it takes. So neither of these should be too long. Recall that the greedy coloring algorithm, well, first of all, what's a coloring? What's a proper coloring? A proper coloring is an assignment of colors to the vertices of a graph such that no two adjacent vertices have the same color. So how does the greedy coloring algorithm color a graph? It looks at each vertex in some order, and then it looks at the neighbors of each vertex to see what colors are used by those neighbors, and then it just assigns the first unassigned color that isn't being used by its neighbors. So let's see what that tells us. First of all, does it give us a proper coloring? Yes, because we never assign a vertex a color that is the same as one of its neighbors. So that part's easy enough. Okay, it does the right job. But what does it tell us about how many colors we need? Maybe that's not a question I asked you, but that is actually something that we can tell right here. We can ask ourselves, how many colors will we need? Well, it's going to depend on what the maximum degree vertex is in the graph. This will be based on the maximum degree of a vertex in G. We're going to call this big delta G. And if you don't remember, the degree of a vertex is just how many edges are coming out of it, or how many neighbors it has in this case. Because here we're just talking about undirected graphs, simple graphs, every vertex. We don't have multiple edges or anything like that. So the degree is just the number of neighbors it has, essentially. So how many colors will we need? Well, I will never need more than the number of neighbors I have plus 1. So the number of neighbors, we'll say the degree plus 1. So we'll actually say the max degree. I'm gonna change that really quick. And why is that? Well, let's consider a given vertex. I will look at how many colors have been assigned. I can never use more than delta G colors for its neighbors. On the neighbors of a vertex. So, one of the first delta G plus 1 colors must be free. Okay, so I'm going to continue this thought up here just for fun. So we conclude, so let's define this thing. The chromatic number of a graph is the maximum number of colors, or actually it's the minimum number of colors. Needed to properly color the vertices of the graph. So by this greedy coloring algorithm, I see that the chromatic number of G has to be less than or equal to the maximum degree of G plus 1. Why is that? Because I can always color a graph using delta G plus 1 colors. So the minimum number of colors needed will be at most delta G plus 1. Because, as we said back here, I'm never going to use more than delta G colors on the neighbors of a vertex. So I'll always have one of those first delta G plus 1 colors to use for coloring any vertex. So that's kind of nice. The greedy coloring algorithm actually tells us something about this chromatic number of the graph. So that's kind of cool. How long does the greedy coloring algorithm take? Well, that's a slightly different question. And it's actually not too bad of a question. So let's take a look at what we do. We look at each of the vertices in some order. So I'll write that. So when we look at the vertices, that's going to take about size of v time. And then we look at the neighbors of each vertex. And whenever we're looking at the neighbors of vertices, that basically means that we're going to look at each edge twice. So if I look at the edge UV, so look at each edge twice. For example, the edge UV, at one point I will look at U, and then I'll look at its neighbor V, and then at another point I'll look at V and its neighbor U. So during this step, I'm going to be taking about 2 times the size of E steps. And then we assign a color. That should take about constant time. So, these are all technically big O notation over here. So the total time should be, it's going to be linear in the number of vertices plus the number of edges. And that is our answer there. So, what did we see in this video? We saw that the greedy coloring algorithm is correct, and moreover, it tells us something about how many colors we might need to color the graph, and it gives us an upper bound for how many colors that might be. And that upper bound is the maximum degree of a vertex plus 1. Also, we saw that the greedy coloring algorithm just takes time linear in the number of vertices and edges. So there you go. There's a little bit more about the greedy coloring algorithm.